Hello and welcome back. So last time we saw how we can go from a truth table to a um, Boolean expression by converting the truth table to a sum of products form and then simplifying it. I promised you that I would show you an easier way, a more graphical way to convert a truth table to a Boolean expression, which is called a K-map or a Karnaugh map. But before that, I need to show you something called a gray code. So the gray code is a system, a sequence of binary numbers, such that consecutive numbers differ by only one bit. So gray code with length 1 is just 0 and 1. They only differ by one bit because there's only one bit. And then for the length 2, we have 0, 0, 0, 1, 1, 1, 1, 0. And you can see that every consecutive number differs by only one bit. Something to notice is that the gray code sequence is a circular sequence, meaning um, the last element, the last number, 1, 0, and the first element, 0, 0, in the length 2 gray code fits the criteria such that they only differ by one bit. Now I want you to pause the video and think about how we can construct gray code of length 3. I would recommend looking at the relationships between gray code with length 1 and gray code with length 2 and how that might help us construct length 3 gray code. All right, welcome back. Hopefully you paused the video and had some time to think about this. And now I'm just going to show you the answer. So what you do first is you write down length 2 gray code sequence in its order, like so. And then you write it in reverse. 1, 0, 1, 1, 0, 1, 0, 0, right? And now you can notice that except for the place we switched, we started the order in reverse, which is like here. All consecutive numbers only differ by one bit, which fits the gray code criteria. And then what we do is we add zeros to the front of the first four numbers and then ones to the last four numbers. And now where there was no difference has one different bit, which was a change from 0 to 1. And all other places, the only difference is the difference from before, which still fits the criteria. And that gives you the length 3 gray code. So we can see that there's a recurrence relation here. To get the gray code of length n, what we do is we get a list of the sequence of gray code with length n minus 1, and then a list of that reverse of that sequence, which is reverse of L1 that we've seen before. And then we put a 0 on before every element in L1, and then we put a 1 in front of every element in L2. And then all we need to do is put the two lists together, and now we would have a gray code sequence of length n. Hopefully that made sense. Let me know if you have any questions. And in the next few videos, we'll be talking about the Karnaugh map or the K-map to simplify and construct Boolean expressions from truth tables.